Everyone who rides in or drives a car wants to get the best ride they can possibly get, whether they drive a roadster, a minivan, or even an SUV. Tire balance is one of the most important factors in good ride quality in a vehicle. So if this is so important, why exactly does the tire need to be balanced, and what does that mean anyway? In this video, we demonstrate the need to balance a tire for a smooth ride, as well as some of the most common methods used in the industry today. As it turns out, there's actually quite a bit of math involved in balancing a tire. Small heavy spots or light spots within a tire that are produced by manufacturing will cause the center of gravity of the tire to shift away from the center of the wheel, causing an imbalance in the mass of the wheel. These light and heavy spots within the tire will cause either a static or couple imbalance, or a combination of the two, also known as a dynamic imbalance. A static imbalance is one where the center of gravity of the wheel is shifted away from the center itself, causing the wheel to go through an up and down motion, as seen at the top right. A couple imbalance is one where the weight of the tire itself is evenly distributed about its center, but is unevenly distributed to the sides of the tire, causing the tire to want to wobble from side to side, or rotate about an axis that is not in line with the shaft to which it's attached. This is the aforementioned dynamic imbalance, a combination of couple and static imbalance effects, and is the most common form of imbalance seen in cars today. So the question is, how does this machine tell the operator where to put weights to cause this wheel to be perfectly balanced and to ride as smoothly as it does? Although many tire balancers use mathematical methods and calculations that are considered proprietary information and therefore not available to the general public, the basic equations of rotor dynamics explain to us how these machines might achieve the results that they do. The following diagram outlines our best estimation of how a tire balancing machine may achieve its calculations. After mounting the wheel onto the machine, the tire technician must use a small arm to measure the exact distance from the face of the machine to the inside of the wheel. This will allow the machine to determine the exact distance from its sensor package to the plane on which the weights will be placed. The technician then measures the width of the wheel using a set of calipers, and then inputs this width into the machine, allowing the machine to calculate the distance from plane A to plane D. A pair of small sensors, also known as load cells, will keep track of the peak force at each angle, and a rotary encoder will keep track of the position of the wheel at all times relative to its starting position. Once this force has been measured, this may translate into an equivalent mass at this particular angle that it was measured at. So for instance, sensor B and sensor C would each measure a maximum force at a particular angle. This force would then translate into an equivalent mass at the same angle. Keep in mind that in order to dynamically balance a tire, we must solve both the couple imbalance and the static imbalance of the tire itself. The first one we will solve is the couple imbalance. Solving the couple imbalance will be easiest if we take the summation of all moments about plane A. Solving these equations will give us the mass we need to place on the outside of the wheel and the angle at which we need to place it in order to counteract the couple imbalance in the wheel. Next, we'll solve the static imbalance. Again, using vector analysis, we'll take the summation of all moments about plane C, or the sensor. Solving these equations will yield the mass that we need to place on the inside of the wheel and the angle relative to its starting position at which we need to place it in order to completely dynamically balance the tire.